This is the flywheel. Hi everyone, welcome to my YouTube channel. In this video I am going to explain you about one of the very important experiment from mechanics, that is determination of momentum of inertia of a flywheel. Before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. Okay, so let us start today's experiment. That is aim of this experiment is to determine the momentum of inertia of a flywheel from the graph of applied couple against angular acceleration. So here first we need to understand what is momentum of inertia. That is summation of what, product of mass of each particle into square of the distance from its axis of rotation. So we have to determine momentum of inertia of a flywheel from the graph of applied couple. We have to plot the graph of couple versus angular acceleration. So we will get to know the momentum of inertia. So apparatus required here are flywheel, set of weights of 50 gram each, stopwatch and vernier caliper. So first we need to understand what is flywheel theory. You have to understand a flywheel is heavy wheel with a long axle supported in bearings such that it can rest in any position. Its center of gravity lies on axis of rotation. Okay, you can see in this figure clearly the how actually flywheel looks like. Okay, it is a heavy wheel with a long axle supported in bearings. It is supported by bearings such that it can rest in any position. Its center of gravity lies on the axis of rotation. Okay, so the momentum of inertia of a flywheel is given by the rotation of torque. Flywheel is given by ratio of the torque ratio of torque versus angular acceleration. So I is equal to T by alpha. So T is what? Torque, that is mass mgr, mass gravity into radius, then angular acceleration. So alpha is what? Angular acceleration. So alpha is equal to 4 pi by n1 into n2 by t2 square. So n1 and n2 are number of rotations. You will understand in the tabular column. T2 is time taken for each rotation. So here observation you have to note down. Vernier caliper least count, you have to calculate the least count of vernier caliper. That is one main scale, one division on main scale, and the total number of divisions on vernier scale. So the least count of vernier is 0.01 centimeter. So least vernier is helpful to measure the diameter of the axial. So diameter of the axial you can note down from vernier that you will get around 1.98 for a given flywheel. You have to take 3 trials, 3 readings you have to take, and then you have to take the average of 3 readings. You will get mean value, that is diameter of a axial. Then mean radius of axial, that is given by diameter divided by 2, 1.02, that is radius of a given flywheel axial radius. So number of turns on the axial, that is going to be 10.
ಇಲ್ಲಿ ವೇಟ್ ಹಾಕ್ಬೇಕು, ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಇದು 10 ರೊಟೇಷನ್ ಆಗಿದೆ ಆಕ್ಸೆಲ್ ಮೇಲೆ.
ಹಾಂ,
ಈಗ ವೇಟ್ನೂ ಇಲ್ಲ ನಮ್ಮಲ್ಲಿ, ವೇಟ್ ಅಟ್ಯಾಚ್ ಮಾಡಬೇಕು.
so first you have to understand the procedure of the experiment. First you have to do what you have to do, find the mass of the pan m1. So weights whatever you are taking, 50 gram, 100 gram, like that. So mass of the pan, you have to find out. Second thing, measure the diameter of the axial using vernier caliper as you have written in the observation. Measure it 3 times and find the mean diameter d, then radius of the axial you will find out. Okay, as you have written, you can see the radius of the axial here they got 1.02 centimeter. We have to find out radius of that axial. Here you can see the diameter of axial as you will measure from the vernier caliper. The total reading is equal to what? MSR plus CVD into least count. Just you have to measure 3 times and take the average, you will get the radius. So the next what you have to do, adjust the length of the thread so that when the pan touches the ground, the thread detach from the axial. Then after attaching the thread to the axial, rotate it so that the pan is raised from the ground. Count the number of turns from rest until the pan touches the ground. Next, put some mass M2 in the pan. Let off the pan without any jerk and it starts going down. Start the stop clock as soon as pan touches the ground and also starts counting the number of turns N2 the flywheel completes until it stops. Stop the stop clock as soon as the flywheel stops rotating and T2 is not. You have to note down. Repeat same steps 5 and 6 for different masses and tabulate the reading. So here
साइंस का है
हाँ सर मार्क्स में
तो उम्र के लिए 250 ग्राम ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ಇದು 0 ಆಗಬೇಕು ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕು ಇದು ಕೆಳಗೆ ಬೇಕಂದ್ರೆ ಇಲ್ಲಿ ಕೌಂಟಿಂಗ್ ನೋಡ್ಬೇಕು ಅದು ತಾನೇ ಕೌಂಟ್ ಆಗ್ತದೆ ಆ್ಯಕ್ಚುಲಿ ಈಗ
ಹಾಂ
ಈಗ ಇದು ಬೇಕಂದ್ರೆ ಇದು ನಾವು ಸ್ಟಾಪ್
ವಾಚ್ ಯೂಸ್ ಮಾಡಿ
ಇದು ಎಲ್ಲಿ ಹೋಗಿ ನಿಂತು ನೋಡ್ರಿ ಅಲ್ಲಿ ತರ ಟೈಮ್ ಪೀರಿಯಡ್ ನೋಡ್ಬೇಕು ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ರೊಟೇಷನ್ ಎಷ್ಟಿತ್ತು ಅದು ನೋಡ್ಬೇಕು
ರೊಟೇಷನ್ಸ್
ಎಲ್ಲ ನೋಡ್ರಿ ಈಗ ಎಷ್ಟಾಗ್ತದ
ಎಷ್ಟದ ಸರ್
25 ಆಲ್ಮೋಸ್ಟ್ ಅದು 24 ಆಗದ ಈಗ ಆಲ್ರೆಡಿ ಈಗ 24 ಆಗದಂದ್ರ ಇದ್ರೊಳಗೆ 10 ಮೈನಸ್ ಮಾಡ್ಬೇಕು ಯಾಕ ಎಷ್ಟು 10 ಆಲ್ರೆಡಿ ಇದು rotate ನೋಡ್ರಿ 10 number of turns so actually 14 ಆಯ್ತು ದ ರೀಡಿಂಗ್ಸ್ 14 rotation ಸಲುವಾಗಿ ನಮ್ಮಲ್ಲಿ ಟೈಮ್ ಪೀರಿಯಡ್ ಎಷ್ಟದ ಅದು ನೋಡ್ಬೇಕು ಇದು ಸ್ಟಾಪ್ ಆಯ್ತಂದ್ರೆ ಸ್ಟಾಪ್ ವಾಚ್ನ ಸ್ಟಾಪ್ ಮಾಡ್ಬೇಕು ಕರೆಸ್ಪಾಂಡ್ ಈ ಪ್ರಕಾರ ಅದು ಆಕ್ಚುಲಿ ಹೆಂಗದ ಇದು ರೀಡಿಂಗ್ಸ್ you have to take this number of trials in increasing order. First you applied 50 grams 100 150 200 250 in each weight you have to take 2 times and note down the corresponding time.
Here is the tabular column. So you can take maximum 4 readings here. So mass applied in gram 500 1000 1500 2000. So number of rotations made by the flywheel after weight touches the ground N2. Here you have to take 2 times reading. So first time what you will how much number of rotations you will get 24 and for that corresponding time taken by the flywheel after weight touches the ground until it stops T2. Here they got for 24 rotations time taken is 20 seconds. Then repeat same procedure again and note down the second time reading 25 rotation they got 18 second time. Similarly for 1000 1500 and 2000 you have to repeat the procedure. Then what you have to do, you have to take mean. For 500 first reading 24 plus 25 you have to add and divide it by 2, you will get the mean. And second time 20 and 18, you have to add and divide it by 2, you will get the 19 for 500 gram. Then next what you have to do, N2 by T2. So mean is what, N2 for rotation, T2 is what, mean for time. So here first reading, if you take 24 by 19, if you will divide it, you will get 1.26 ratio. Then square that ratio, you will get the value in the final column. So repeat this calculation for other 1000 to 1500 and 2000. After calculating this N2 by T2 ratio, square of that, what you have to do here, so after taking the readings, you have to plot the graph of mass versus the ratio that you have calculated in tabular column, N2 by T2 square along x-axis and mass along y-axis. After plotting the graph, you will get the straight line and take the slope of that, AB divided by BC. Then you can calculate the momentum of inertia from graph, and also theoretically you have to calculate. So here is the graph of mass versus the ratio of N2 by T2 square. So you can plot the graph, you will get the straight line, and here they have calculated the slope AB by BC, that they got about 260.41. Okay. Next, after calculating the slope, the momentum of inertia of flywheel, that is given by formula GRN1 divided by 4 pi into slope. You have to substitute the values here. You will get the momentum of inertia. G is gravitational constant, acceleration due to gravity, R radius, N1 number of turns, 10. Okay. You will get the momentum of inertia about 2.07 into 10 to the power 5 gram per centimeter square. This is calculated from graph. Next, theoretically, you have to calculate the formula as we have written in theory. Momentum of inertia is equal to torque by angular acceleration. So torque is what, mg into r, mass into acceleration due to gravity into radius. Calculate for 500 gram. So first reading, like that you can calculate for 1000, 1500 and 2000 gram. So this is for 500 gram. Then alpha is equal to what, 4 pi n1 n2 divided by t2 square. Then put the values here. So n2 by t2 you can get from tabular column for 500 gram. So write down that value here and calculate. You will get the alpha angular acceleration. After calculating angular acceleration, you can just in this formula t equal to I equal to t by alpha. So I equal to t by alpha value you can put, and you will get the momentum of inertia, that is about 2.42 into 10 to the power minus 10 to the power 5. So this is quite near to the uh, experimental value. So these two values, like theoretical and this graphically what you have calculated, momentum of inertia are near. So whatever the experiment you have done is going to be correct. So this is how you can determine the momentum of inertia of a flywheel. Is equal to 2.07 into 10 to the power 5 or 2.07 kg meter square. So I hope this experiment or video is helpful for you. If it is helpful, please like, share and subscribe my channel. Thank you for watching.